right, what about number 7? Function or not a function? Not a function. Why? There you go. All right, what about number 8? Function. Okay, here's what I want to bring to your attention on number 8. Do you see how you have 2 9s, but one is in the X spot and one's in the Y spot? Okay, so just slow down on these. Just slow down. All right, what about number 11? Does it pass? Nope, it hits twice. What about number 12? Yep, it only hits once. We're going to say 13 for tomorrow. Okay, what about 15?
It'll be 8x 6y plus 7.
Very good. Subtract the 8x. And then subtract the 7. Luke, does this not come up? Just shut it down, and when I come to your little group, you can take. Did it come up?
Yeah.
Oh, okay. All right, so there's 3 things you can't have. You ready? What's standard form? Can't have a leading negative. Can't have. Oh, no. That's linear. That's linear. You can't have fractions, right? And then you cannot have the GCF other than 1, right? The exponent was when you were determining if it was linear or not. Okay? So divide by -1. What? Okay. You're all good? Anybody lost? No, you're not? Okay. Alright, you got your calculators? Because as long as you have a calculator, like today is like ridiculously easy. I mean, it's like I'm insulting your intelligence. It's so easy. No, it's easy. It's easy. Huh?
Did you ask that question?
What did you do?
She's like, can I happen?
No. You know better than that. Exit out and do it again. Alright, what are we on? Page 9? Is that what it says? Yeah, page 9. Page 9. Okay. I know, I kind of take out some pages here and there. Alright, y'all ready?
Yes, I am.
Okay, here we go. What's the title of today's lesson?
Rate of change is slow.
Very nice. So, instead of saying slope, you could say what?
Rate of change.
Rate of change. There you go. All right, so rate of change is the ratio that compares how much one quantity changes versus how much the other changes, right? Okay, so here we go. So you remember the formula to find slope?
Y equal mx plus b.
No, that's the slope intercept point.
Y2 minus Y1 over X2 minus X1.
There you go. Y2 minus Y1 over X2 minus X1, which we are now going to learn that we just say that.
Y over delta A.
Very good, Sebastian. All right, here we go. So, here we go. When you go to the store and you actually have, like, cash, right? You know, it doesn't happen very often, but we do have cash. When you go to the cashier, how is she going to make your change? Is she going to add, subtract, multiply, or divide? She's going to subtract. So that's what change means. It's just the same formula you always use. We're just going to write it a little bit differently. So here we go. You have to compare each one of those numbers. So you have to pair each one up. So what's my first pair over here?
What do you have to say?
The triangle, delta y. Yeah. What's my first pair?
0, 1, 4,
And?
0.
Very good, very good. Time is always your x, and y is your temperature, right? Now be careful. What's my next pair that I'm going to compare? Oh, no, it's not. 2 and 5. Melody, very good. All right, what's my next one that I'm going to compare? 5 and 8, and one more. Okay, so what we have to do is we have to compare all of their rate of change to see if they're the same or to see if they're not the same. Does that make sense to everybody? All right, so you do not have to write all of these out, but let's write the first one out just so that for our notes purposes we can see what we're doing. So it does not matter which one of these y's you start with. Which one do you want to start with?
2.
Y's.
143.
143.6, okay? It does not matter, guys. All right, we're going to subtract that from 139.4. Here's what matters. What matters is that you match the y with the x. So what was the x that went with this y? 0 minus 2. That's the only thing that matters. So Cameron, if you wanted to do 139.4 first, that's fine, as long as you did the 2 first. Okay? All right, so then just subtract them, guys. And what do you get? Over?
4.2.
Over negative 2. Divide them, and what's the rate of change? Negative 2.1. Y'all okay? All right, so what's this mean? This means for every how many minutes? 2 minutes. What's happening to your temperature?
It's going up. It's dropping -1. I mean -2.1.
Well, if you say drop, you don't have to say negative. So it's dropping 2.1 degrees. Okay, degrees, what does that say? Celsius? All right, so look, you don't worry about writing this out anymore, but go find your partner in just a second. Delta y over delta x, and then I want you to compare 2 and 5 and give me your answer. You do not have to write it down, so here we go. What is the change in the y's between 2 and 5?
I'm just gonna. It's
The y's.
139.4 minus 133.
How much? 6.3, that sounds about right. And then what are my changes in the x's between that same pair?
-3.
-3. Remember, you have to do them in the same order. And then,
-2.1.
is it the same so far? Hey, look, I promise you, when you stop, that's going to be the time that they change right after that. So make sure you check all 4 pairs. Okay, does that make sense? All right, find your partner. Here's what we're going to do. We're going to work number 1. We're going to finish number 1. And we're going to work number 5. And then we're going to come back together. All right, find your partner. Go. Okay, let's see. Kaylin and that. Y'all, no. Just one, Kaylin. Just go to that. No, just the other one's still messing up. Kaylin, go to the computer. Go ahead and. Do you have your laptop?
Yes.
Okay, pull it up. Luke, do you have your cell phone? All right. Melody, do you have your cell phone? Melody, do you have yours? All right. All 4 of y'all go ahead and pull your devices out. Take your quiz, and I'm going to stand right here to make sure that, everything's where they're supposed to be.
I know that you're ready for this. Are we doing this? Number 1 is right there. Yes, it's big, mine up there.
And then only thing that matters that you heard was the x. What's the x? That was 143.6.
Oh, 0.
What's the x that was 139? That's why they have to be in that 0. Okay? You can switch these around as long as you just do it.
One and you subtract.
The negative.
It would be the same.
Mom.
Right, so then you can share the home, so the 2 is 5.
Oh, that's right.
They're all the same, then do they have a constant rate of change, or do they not? Just doing 1 and 5, guys. Just doing 1 and 5. Okay? Yeah.
What happened was I used my personal Gmail to sign
Yeah. Grab it, just
Exact five?
So, yeah.
Alright, so on number 1, did y'all get negative 2.1 between 5 and 8? And then did you get the same thing between 8 and 12? Alright, so is this a constant rate of change or not a constant rate of change? Constant rate of change, there you go. What?
Can I abbreviate constant rate of change? Or I have to write it?
I mean, we're only doing 2 problems. I think we'll be okay. What's wrong, Cameron? We're on number 1?
Yeah.
Which one did you do?
Okay, I did for 5 and 8.
Yeah?
And I got negative 13.7 over negative 3. Because it was stuff. And I was supposed to go.
That's why. You must have hit a number in somewhere wrong.
Yeah, I think I did.
Okay. Alright, then we're going to 5. Then we're going to 5.
I don't know what that fraction would be.
I'll do 12.
Is that true?
1 and 2. You see it down there at the bottom?
No.
So that definition is the slope. So the slope of a line is the ratio that compares the y values, the y coordinates, to the x coordinates. Okay? Alright, so how do I find the slope between two ordered pairs like that? Uh-oh. Changing what? You don't have to say y 2 minus y 1, but it doesn't matter, right? Okay? That's why we say change instead of doing that formula. So we're going to say, you can say delta if you want instead of change. Same thing. Alright, so you're going to say delta y over delta x. Right? It doesn't matter the y's. So which one would be easier to start with? What are your y's? -3. -5. There you go. Alright, and your x's, it doesn't matter the x's as long as you put them in the same order. So what's the x that goes with -3? 1 minus 3. So that's -8. Yeah? And so what's your rate of change? 4. So if you were to graph those 2 points, your slope between them would be 4. Y'all okay? Alright, y'all try number 2 real quick. I told y'all today was easy, right? Alright, Dalton, have you taken yours? Alright, we're Diane finished it. Alright, is there anyone in this room that has Jonathan, you haven't taken yours yet, which is Dalton's gonna log in, and then you're gonna log in, okay? But I think we're separate the numerical conference. Was that like subtracting? I don't like subtracting. I like adding or subtracting. We have the same question.
It's underlined, but no, it's underlined. You're not divided by 0. You just tell me the answer is 0. You're not just the answer is 0.
Undefined.
Okay, well, we should have plenty of time. Don't worry. Wait until we get finished with this, and I'll come by and let you and Dalton both do it. Okay. All right. Here we go. Change of y over change in x. Did y'all do 7 minus -1? 8 minus 8 was 8 over 0. If you type that in your calculator, it will not give you 0. It will give you an error. So what is the answer?
Undefined.
Undefined. All right. So if it is undefined, what kind of a line has a slope that is undefined? A what? A vertical one, Dalton. Very good. All right, flip over on the next page. We got 3 and 4. Yeah, because I don't. Was that page 10?
Sebastian said we thought we were done. That's what the board says. No, it's 9 through 11.
9 through 11. Yeah, this is the last page. This is it. All right, Dalton and Anna, go ahead and take the phones out. Put them in the classroom.
Can 0.6 be a slope?
No, we always do a fraction.
Especially negative six, say you would
Negative 6.
divide.
You would want to keep it as a fraction.
But you
You
want
would
to divide.
reduce it. You would reduce it.
You reduce. What number is?
Number 3.
All right. Well, Sebastian, what did you subtract?
1 minus 5.
Oh, that's where you went wrong. It's 1 minus because you have to subtract, and then your otherwise negative 5. All right, and then that's going to be 4 minus negative 6.
I always put my negative first because I get.
Yeah, but well, sometimes you can't always do that. But yes, that's what I normally do.
I try.
That's what I try to do too.
Then I'm like trying to.
That's why I tell y'all that it doesn't matter the order. That way you can
Yeah.
tell.
You guys will do it.
No, you don't want to. Y'all okay on 3? All right, are we finished with 4? Which ones did y'all do? No, like like the order. The order.
Oh, I did.
Okay, and then you did
Negative 8 minus 3.
perfect. So let's see, that's 20 over negative 32. When you divided by 4, yep. So that's negative 5 over 8.
Whoa, I got that wrong.
Oh,
Yeah,
what happened?
I thought it was 20 over 30.
So I got negative 13.
You did get negative 20 over 32. Yes, ma'am. Then you have to reduce.
I got 13.
Where did you get 13 from?
Okay, so I did 24 minus.
Oh, no.
I
Change
did
your Y.
That's
Y's gotta go
that's a
first.
whole math right there.
What? Me.
You're the only one behind
Check out
me.
the videos.
I have common sense. I don't have eyesight, but I have common sense.
Yes, Danielle. Yes. What about
So here we just
Yes. Yes. Alright. We're moving to the bottom 4 and then that'll be it.
sister this question. Child. Because I thought this was.
I know. So I didn't know if you used it right now. I didn't hear you said. Sorry.
Alright, you ready for the bottom 4? Alright, let's look at this. I'm gonna zoom in. Y'all with me?
That was so awkward, though.
Waiting on y'all. You ready? Okay. Ladies, y'all ready? I guess I'll take that as a yes.
Yeah.
Okay. So, be very, very, very careful. Do you see right here where, like, it just barely does not cross? You cannot make that a point, okay? Same thing here. You cannot make this a point because it does not cross. So, I see one right here.
Or you can use the axes.
I
Let's use
see
the axis.
that one.
Axis.
Axes. Yeah. But sometimes it's not always, yeah, like Bill said. Alright, so it doesn't matter which one you pick. But I would not pick the furthest ones apart if I were you because then you'll have to reduce. So pick the two that are closest, either these two or these two. You'll get the same answer, but it's just easier not to reduce. So let's see, we're going to go up 3. And we're going to run to the left.
Negative.
There you go. And we normally put the negative out to the front. Are y'all okay?
I didn't know.
It'll work the same way, but when you have a graph, that's kind of doing more work for no reason.
Yeah.
So, it's practice. You can do that, yep. But on the ACT, if they give you that, like they did one, because didn't we go over 11 and 12 the other day?
No.
No?
Yes, we did.
We did go over them?
So how do you write
Did we? Yes, we did go over them.
How did you do that?
Right, just like that.
1 and 1? Or just 1? Okay, hold on. Okay, well, I'm still trying to do next. Hold on, so they're rising back. I'm here. 1.
No, I need the further ones apart on that one. If you can't tell, it's the furthest one apart.
I can do all of them except for
It's hard to tell. You can't tell when they're touching, can you?
on number 2.
You can't tell when they're like that. So it went up 5. One
Time I asked about this open petty election say actually that's enough competition.
Bless you. All right, Jonathan, you want to go ahead and log into the computer by me and take your quiz? Abby and Dalton, did y'all finish? All right, sweet.
Okay, so for number 2, what's one?
I'd probably use the farthest ones apart because the other ones kind of like they're iffy, and you don't ever want to use an iffy one. Let's see, 2, 4, 6, 2, 4, 6, 8, 10, 12, 13, 16. All right, be careful on number 2 because what is your graph counting by? 2. This line right here is 2, then 4. Yep. Then divided by 2, so you should get 3 over 8. Y'all okay? Yeah, if you found a closer one, Kira, then it'd be fine. Which one did you use?
I still use those. I just did it like I didn't use it. I did it by one.
Yeah.
If it wasn't counting by 2s, you got real lucky. Got real lucky. All right, what about 3?
It's 1 over.
Okay, so right here, it is not 1 over 1 because what are these counting by? 5. So when you go up 1, it's going up 5. Then your x's are counting by 1, and that reduces to just 5, right? Y'all okay? You just got to slow down and pay attention. Those ACT problems love to put these on there where they're counting by something different on the x and the y. They love to put those. Because it's counting by 5s on the y. No, they're not. That line in between there is halfway between. What's halfway between 10?
5,
There you go.
10, 15, 20. Oh.
Got it? But then the x is still counting by 1.
So,
All right. Wait. What?
I got this one. I feel confident. It's -4.
okay, yes, that's my thing. How did, like, you get -4 because you get 4 over -1.
Yeah, because you're going up 4, and then
Like,
you're
if someone
going.
was just to see
There's
your
an
slope
understood
-1, how would they do it?
There's an understood one.
My slope is -1. The slope's not -1.
No, I'm saying though, like, when you take the 1 away, you get -4.
Mm-hmm.
So how would, like, someone who just saw -4 know that that's slope?
Oh, because you can make 4 a fraction by putting it 4 over 1, right? And so if it's negative, that means you're either going up 4 and left 1, or what's the opposite of going up and
Down
left?
4 and right 1.
So it doesn't matter which one's negative.
Okay.
So that's why they, when you see it on the test, that's why they always put the negative to the front, because it doesn't matter where it goes. Okay.
Okay,
Are y'all okay? Yeah? No?
Let's get this checkpoint go.
Okay, go ahead and get back where you're supposed to be, and we're going to do a checkpoint for the rest of the class period. You've got, like, what, 15 minutes to do a checkpoint?